Weirdly, you need your unit circle out. I know this is a shock, but you're going to need your unit circle out. So, we're now going to graph trig graphs and do transformations to them. And if you're like, transformations, remember I told you it comes up in every unit from now until eternity. It doesn't go away. Those bad boy transformations are here to stay. Yes. So we are going to sketch the sine graph. The sine graph, really what it is it's this, we start here, which is 0, correct? And then we're going to go around in a rotation, as if this was like a Ferris wheel or something, right? And then we could keep rotating, keep rotating, keep rotating, or we could go backwards. And what we're going to end up actually doing is making a graph of that horizontally. We're basically taking this circle and unraveling it onto a graph. Okay? Sine is what values on the unit circle? Why? Because it's Calgary, Stampede, right? So we don't even care what the x's are. So at 30, at 45, and at 60, you have your unit circle drawn in front of you, so you're okay. That's not 60. Come on, let's grab a mitt. Get in the queue. 45, 60, 90. We agree? Those are actually all my x coordinates, because those are the thetas. The theta is in for the variable for x of your equation, right? So for the sine graph, these are all my, and we're going to take the radian measure, but I'm just going to show you it in degrees anyways for now. I can get the coordinate of a sine graph right off of the unit circle. The degree or the radian measure is your x, and the y is your sine. So at 0, what's sine? 0. At 30, what's sine? 1/2, right? At 45, it's 2/2. At 60, it's 3/2. At 90, it's 1, right? Which we can actually label 0, 0. Pi over 6, 0.5. Pi over 4, 0.707, blah, blah, blah. Pi over 3, 0.866, blah, blah, blah. And then pi over 2, 1. And we can just keep going, correct? And those get us coordinates that we can draw. So we're going to draw for the sine theta graph. No transformations. This is the parent function of the sine theta graph, just like we did the parent function of the x squared graph in grade 11, right? We have 0, 0. If this is a half, this is the way we can split it. So this is what I need to teach you. Paying close attention. If the x-axis is in radian measure and we don't know what the labels are, you can do this every single time and it will work. Count how many spaces to get you to pi. Okay? So this could be 1 space, 2, 3, 4, 5, 6 spaces, correct? So actually, every single one of these is pi divided by 6. It can take me 6 to get to pi, right? So this is pi divided by 6. This would be 2 pi divided by 6. I'm just going to write it up here, but don't write it up here because we're going to erase it. 2 pi divided by 6 reduces to what? Pi over 3, right? I'm going to erase all the ones above, just so you know. These are all going to go in. And then this would be, so this would be pi divided by 6, 2 pi divided by 6. This would be 3 pi divided by 6, which reduces to pi over 2. This is 4 pi divided by 6, which is 2 pi over 3. This is 5 pi divided by 6, which doesn't reduce, so it's 5 pi divided by 6. This is 6 pi divided by 6, which is pi. This, you can keep going. 7 pi divided by 6 doesn't reduce. 8 pi divided by 6 reduces to 4 pi over 3. 9 pi divided by 6 reduces to 3 pi over 2. 10 pi divided by 6 reduces to 5 pi over 3. 11 pi divided by 6 doesn't reduce. 12 pi divided by 6 reduces to 2 pi, correct? So I literally just count the spaces to pi and then just give her. 1 pi over 6, 2 pi over 6. And then these ones are all going to go away. Because they're the non-reduced form, right? And now we're going to plot our points versus time. So we have 0, 0. We have pi over 6.5. So this is 0.5 and this is 1. This is negative 0.5 and negative 1. Because the sine graph maxes out at positive 1 and negative 1, right? Because the unit circle maxes out at positive 1 and negative 1 for y's. So we have 0, 0. We have pi over 6 and 0.5. In between these two, directly in between them is a 45, right? So this would be where I would locate my pi over 4. So pi over 4 and 0.707. This is 0.75, so it's just a little bit higher. Pi over 3 and 0.866. Pi over 2 and 1. And then I just keep going around the unit circle. What's 2 pi over 3 at? What's the y at 2 pi over 3? Look on your unit circle. What's the y at 2 pi over 3? Root 3 over 2, right? 0.866. What's it at 3 pi over 4? Because that's the in-betweener. 0.707, right? Root 2 over 2. And then at 5 pi over 6, it goes back down to what on the y? Positive 1/2. And then at pi, what's my y? 0. At 7 pi over 6, what's my y? Look at 7 pi over 6. What's my y on the unit circle? Everyone needs to find it because I can draw these really well, but I need you to be able to. 7 pi over 6. Look at the y. What is it? Negative 1/2. So I'm coming down here now. 4 pi over 3 is what? Negative 0.866, right? Can I do the one in between? And is he at 0.707? And then at 3 pi over 2, it's actually at negative 1. 5 pi over 3 is at 0.866. The in-between is at 0.7. 11 pi over 6 is at negative 1/2. And then 2 is here, and we just connect them in a nice hill formation, not a V. It rounds. Okay? So, how hard is it to make the graph? Not hard if we just use our y's and our thetas as our x's, right? And our y's are actually our y's. Because that's what sine theta. So, why is our y? Because sine of 0 is actually the y, right? Which is 0. Sine of 30 is actually the y, which is 1/2, correct? Because that's how we found those outside values. So that's what the graph looks like. It maxes out at 1. It mins at negative 1. It's completely cut in half horizontally at 0. That's your sine graph. Okay? It starts at 0, 0. Okay? We're going to go through this. It repeats itself. So period on here, the period is the length of the interval of the domain over which the graph repeats itself. So this graph currently has not repeated itself yet. I went from 0, 0, I went past a max, and then I went past a min, and then I got back to 0, 0, and then after this point it's going to start repeating itself again, isn't it? Because we start the circle all over. So where does this graph actually not repeat itself from? 0 to 2 pi, correct? And then after that it's going to repeat itself again. So the period of a basic sine graph equals 2 pi, or 360 degrees if it was actually in degrees, right? So a sine graph repeats itself every 2 pi or 360, which makes sense because after we hit to 360, we're going to repeat that circle again, aren't we, when we go to keep regraphing it. Could we graph in the negative way too, with negative angles? Yeah, we just have to go using our unit circle backwards, right? Because negative 30 would actually be at the same spot as 330, right? And then we just keep plotting it that way. The other definition we have is amplitude. Amplitude is half the distance between the maximum and minimum values. Another thing to note, amplitude is always positive. Amplitude is always positive. So I could literally count it and give the amplitude, or I can use the formula. So if I count it, it's half the distance from the min to the max. So this is 1, 2. Correct? From min to max? What's half of 2? 1. So I know my amplitude equals 1 because the distance from the min to the max is 2, and it's half of it. Or we can use the formula. We can memorize it. It's the absolute value of the max minus the min divided by 2. So we can use the formula. Amplitude equals the absolute value of the max. What's the maximum height on this graph? 1. Minus, what's the minimum height? -1. Divided by 2, which is the absolute value of 2. This becomes a plus sign. 1 plus 1. And the absolute value of 2 is 2, so it's just 1. So the only reason where you're going to need that actual amplitude, or the absolute value signs, is if the entire graph is below the x-axis. Because then your min's going to be negative, your max is going to be negative. You're going to tell me your amplitude's negative, and it's not. Amplitude's always positive. Okay? So we're going to go through, state the following for y equals sine theta. So y equals sine theta, our amplitude was 1, correct? Our period is 2 pi or 360 degrees. What's our domain of sine theta? I know we drew from 0 to 2 pi, but does it stop there? Does it stop at 0 to 2 pi? No. So the domain is actually XER, because I can keep going negative and I can keep going positive. The only way it's not is if they restrict me. What's my range? What's my lowest y on that graph? -1. What's my highest y? 1. So we're going to sandwich those numbers. So we're going to go -1, y, 1, and we do 2 less than or equal to signs. They're always in the same direction because you read from the y. So we're going y is less than or equal to 1, and y is greater than or equal to -1. So that's why the symbols are actually in the same direction, because you're reading from the y. And then y in. What's my y-intercept of this graph? 0, 0. And what's my theta intercept? 0, pi, 2 pi. So you're seeing the pattern. The pattern is that it's increasing it's happening every pi and starting at 0. We agree? So how did we do that before? Well, we can give the general solution for these. Remember, the general solution for coterminals was you used the principal angle and you added 360n NEI because it happened every 360. I can do the same here. I can do my lowest intercept, which is 0, and I can add to it, how much does it take to get to the next one? Pi n NEI. The catch is I don't have to write the 0. So if it's any other number, if the first number is anything but 0, I have to write it. If it's a 0, I can just go pi n NEI. Now say I wanted to get a show on my calculator. I'm going to go like this. Into my y equals, I'm going to go sine x. So we go to our y equals, and we go sine x. The catch, though, is I just press the sine button. And what should I always do when I press the sine button? Think, what mode do I need to be in, right? This particular graph, what was the x-axis in? Radians. So I need my calculator to be in radians, right? If I want to see if I actually drew it right. So I'm going to go to mode. I'm going to go, it's already in radians. Sweet. Now my window currently is 10, 10, 10, 10, 10, 10, 10, 10, 10, right? That's the standard 10 and negative 10 is the standard window we use for polynomials, the cubic functions, radicals, rationals, all those things. But we've never had to do the standard for trig. So I'm going to show you. If you're totally lost and you're like, I don't know what to set the window to, you can go zoom. But you only do this after you've changed the mode. Because it's going to put it in a degree window or a radian window depending on what mode you picked. Okay? So we go zoom trig, number 7. And then it'll put it in a trig window. Now that doesn't always work because maybe your graph is above 2 or below 2, negative 2. So you won't be able to see it. So you might have to change your window. But if you're super stuck, you can zoom trig. Now keeping in mind, this window now is actually in radians. Correct? Because I picked the mode of radians. So I always have to, before I even type in sine x, I should pick my mode. Right? Before we touch those buttons. Now, I want it to match the one I actually have. I'm going to doctor my window. Because I might say, yeah, I think that's right. But it's not the same window as what I have, right? If I want to know if I drew my graph correctly, I need to set my window to the exact same window as what I drew. And then it should look exactly the same, and then I will know if I'm right. Right? Because you'll be like, yeah, I think it's the same. Yeah, I think it's the same is scary to me. I want to be like, yes, it is exactly what I have. Okay? So my x-min started at 0. So I'm going to put 0 here. My x-max was 2 pi. Which I'm going to put there. What was my scale? What was each little tick worth? We figured it out. It was pi over 6. What did I make my y max be? 1. And my y min I made be negative 1. And how much was each tick worth? 0.25. And the resolution, don't worry about that. Don't touch it. Change your next. Don't worry about that either. Okay? I must have not put a sign. That's correct. Y min, Crystal, is negative 1. Y max is 1. Not the opposite way around, silly me. Does that look exactly like the graph you have? Probably a little smoother, but generally, yeah. So you know you're right. So we can compare, and the best way to compare if you're told to draw a graph and you're checking it in your calculator is to make the window the same. That's one thing I want to drive home with you because you might think it looks the same, but it might not be. All right. Can you guys do cos using your unit circle? So now your y values are actually going to be your what off the unit circle? All the x's, right? So you can use the thetas like normal, but your y values are actually your x's. Because if I want to do 0, cos of 0 is actually 1. And then cos of pi over 6 is actually root 3 over 2, which is 0.866, etc. So you sketch it out. So my amplitude is still 1 because it's from negative 1 to 1. Still repeats itself every 2 pi, right? That didn't change. We go from a max to a max. After that starts repeating itself. That didn't change. My x-intercepts did change. Those are different. So I have to start at pi over 2. Pi over 2 plus pi n nei. It's still happening every pi. But we didn't start at 0 this time, right? My y-intercept is different. It's at 0 and 1. But my domain and range are the same. My amplitude and period are the same, right? The catch, a cos graph is a shift from a sine graph. That's all it is. It's a horizontal shift. Think about this. If I keep drawing this graph, it would go like this, wouldn't it? We agree? And this is going to happen at negative pi over 2. Wait, culminating thing. If I move this, if I shift it over, I have a sine graph. So a sine graph and a cos graph are just horizontal shifts away from each other. They can be each other.
Ashley
They're
Jordan
magic.
in the next office. Ashley Jordan.